Hi, my name is Welder, a math and statistics tutor. Today we are going to solve a first-order linear differential equation. This kind of equation can be written in this standard form right here. For example, let's imagine a linear differential equation of this kind. 2y prime plus 4xy equals to 2x. This here is not on the standard format, but we can rewrite this equation here in order to write it on a standard format. In order to do that, in this particular example here, we divide both sides by 2. All of this thing here cancels out, and we get precisely this example here. Okay, so let's solve this example. I'll show you what is the main technique to solve first order linear differential equations. The main technique is to find what is called the integration factor. The integration factor is a function mu, defined as the exponential of the integral of the function p, the function that goes along with y. Okay, in our particular case, this function is, take a look here on the example, the px function here is 2x. Okay, and the q function here is x. So plugging the value of the p function here on this integral, we get the exponential of the integral of the function 2x dx. Okay, this is the exponential. The integral of 2x, the integral of 2x is just x squared. It's just x squared. See, when we derivate x squared, 2 comes here in the front, and we decrease the unit here by 1 unit. This is 2x. Okay, I have videos on differentiation in this channel. You can take a look. So here the result is this. So now that we found the integration factor, the next step is to multiply both sides of this equation by this integration factor. So let's do that. Take this value here and multiply it by the two sides here. So doing this from the left side, we get ex squared y prime plus 2x ex squared y. Okay, 2x here I just copy, and y I just copy, and I multiply here by ex squared equals to x ex squared, because I have to multiply in the right side as well. Okay, now let me just resize, not now, after, to gain more space here. What I'm about to show you here now is that on the left side you have a product rule. See, let's remember the product rule. The derivative of a product rule is the derivative of the first function times the second plus the first function times the derivative of the second. See that here we have for p the y function. Take a look that it is derived here and not derived here. And for q you have the function ex squared. See that when you derive the exponential to the x squared power, you get itself, the ex squared function, but you have to multiply by the derivative of the exponent by the chain rule. Okay, and the derivative of the exponent is just 2x. Okay, so this here, the left side, can be rewritten. So this here can be rewritten as the derivative of, with respect to x, is a derivative with respect to x of the product y times ex squared. Okay, this on the left side, and on the right side I will just copy it again. Let me now resize it here in order to gain more space. Okay, and now let me change color and let me integrate both sides. I'm going to integrate this side and integrate this side. When I, let me come to white again, when I integrate a derivative, the integral of a derivative can cancel each other out, and the result will be just the function that goes inside. So because this here is a continuous function, okay, so this here will be y ex squared equals to this derivative here. Let's solve this derivative here on the next page. So let's solve x, the integral of x times ex squared dx. Okay, I have videos on my channel where I discuss what is the most appropriate integral method to use in each case. Okay, you can take a look on it on them, and here I will just take the right path. Okay, and the right here is the one of the best choice here is you to call this here u. You make a u substitution and you call u equals to x squared. Doing this, when you derivate u with respect to dx, you get the derivative of x squared with respect to x, which is 2x. Now passing dx to the other side, you get that du is equals to 2x dx. Now take a look. You can rewrite this integral here the right way. You can put the exponential first. So I'm going to write here the exponential first, and I will put this x dx here after. See that this is very similar here. This here appears here, okay? This 2 here is not is what is making the two things different. So I will pass the 2 to the other side. So doing this, du divided by this 2, because 2 is multiplying here, divided by 2 is equals to x dx. Now I have precisely what is written here. So let me change color and let's continue the computation. So this here will be the integral of exponential. X squared is just equals to u in our substitution. X dx is just du divided by 2. Du divided by 2. I have changed the integral from the x word to the u word, okay, where it is more simpler to solve. So let's continue. I will pass these two. I will take this 2 here from the integral. So this is 1 over 2 1 over 2, excuse me, times the integral of exponential of u. This is the exponential of u. All of this times a constant. Okay, let's continue the computation here, and that will be equals to 1 over 2. EU is just e. Remember that u is x squared, so x squared plus c. This is the result of this integral right here. So let's come back to our exercise and plug this result here. So let's do that. Return it to the first page. So here let me change color again to white, and this will be, it will be equals to, excuse me, I have to continue right here. Let me just move this here above, and let me just divide the, yes, this way here in order to gain more space. Okay, so let's do the computation right now. So continue here. We have all that this here is equals to the integral of this, which is just as we have seen, 1 over 2 ex squared plus a constant, plus an arbitrary constant. Okay, so isolating the value of y, we get, pass this here to the other side, we get this here, I will just multiply by u, will be ex squared, okay, divided by, I have passing this ex squared dividing, so here I will have x squared here dividing this one, plus, and we have ex squared dividing c as well, so ex squared here dividing the c constant. And now see that this and this cancel each other out, so y, let me just resize this expression here in order to gain a little more space here. Y of x, the function that is the solution of this linear differential equation here, is equals to 1 over 2, the result of this operation here, plus c divided by e to the x squared power, and this is the final answer for our problem. So this is the problem that I have planned to show you today. The subject that I have planned to show you, the first order linear differential equation, the main method to solve this kind of equation. So here is an example. I hope you have enjoyed, and if you intend to take a class with me, you can enter in contact, and see you in a next video. Bye.